today's lesson is Riemann sums. It's a way to estimate the area underneath the curve. Our last lesson we used geometric shapes. In this lesson we're going to use Riemann sums, which is part of the definition I told you about. Okay? You have all these partitions, and we want to add up the rectangles. Okay? There's going to be left ones, right, and midpoint. So this is left, right? So you have left. You can come in from the right, goes this way, which is, so this is right. Or you can use the midpoint, and you have a little bit over and a little bit under. All right? And what you're doing is using the y value. So if you're doing a left-hand sum, you're using the y value on the left, and then the width, and you got a rectangle, and you add that up, and you get your area. And then you're going to add up the next one, and the next one, and the next one. Either you do them all from the left, or you do them all from the right, or you do them all from the midpoint. Okay? How do you figure out the number of the width of the partitions? You take b minus a divided by n, which is the number of partitions. Okay? Number of partitions. X is the C value. Yeah, that's the X value. All right. So, you'll notice both these graphs have a concave down graph. And they're asking you, is it an overestimate or an underestimate? Well, it depends. This one was a right sum. So all of that yellow stuff makes this an overestimate. So it's concave down from the right, and you end up with an overestimate. Well, this one's concave down, and we came from the left. It's an underestimate. It's going to matter if you do left or right. Left or right matters, and concave up and down matters, okay? Because here we have concave up, and we're coming in from the left, okay? And it's over. This one was from the left, and it was under. This one's from the left, and it's over. And this one is concave up, and we're doing from the right, and it's under. Okay? This one was from the right and over. This one's from the right and under. So I always draw the picture. Just figure it out when I draw it. Anyway, we're making these rectangles. Left sum. Point at the left. Here's my 4 partitions. All right, so let's do an example. Calculate the left, right, and midpoint sums for this equation with 2 equal intervals from 0 to 8. So 0 minus 8 divided by 2 equals 4. So on my number line, this graph starts here, right? It goes, shh. I'm at 4, and I'm at 8. Now, if I'm doing a left-hand sum, here's the side. The height is f of 0 times 4 plus f of 4 times the width, which is 4. Okay, so I did this one and this one. Most people pull the width out to the side, and then you have f of 0 plus f of 4, which is 4 times 0 is 2, and you do 4 is 16 is 18, so that's 20 times 4 gives me 40. Is that right? Am I right? 8. Oh, f of 4 is 18. Oh, so 20 times 4 is 80. I just can't do my math. Okay, so this was left. Same graph. Goes like this. I'm at 4, I'm at 8. It goes, shh, you come from the right. So I need 4, which is the width of the partition, times f of 8 plus f of 4. So you get 4 times 8 is what? 8 times 8 is 64, plus 2 is 66, plus 4, which we did, was 18. And you do the math, and you get 336. We're going to do units squared. We need some units. And then if we go ahead and do midpoint, they still want two partitions. Okay? So we were at 4 and 8. Well, the midpoint is 2. And the midpoint is 6. So I have 2 times, no, not 2, sorry, take that back. I have f of 2 times the width, which is 4, all right? The height times the width, plus f of 6 times the width. So this is midpoint. And if you do the math, you get 176. Quite a difference here. You have 80, you have 320, 36, and 176. 176 is probably the best estimate. Midpoint usually is. Okay? But you follow the directions. You do what the directions tell you to do. Okay, let's do it again. Left, right, and midpoint from 0 to 2, x squared plus 4 with 4 equal intervals. So 2 minus 0 divided by 4 is a half. X squared plus 1. So I'm up 1 and it's squared. And I'm going from 0 to 2. But the width of my partition is a half. Okay. So those are what I have. If I'm going to do left, so let's start with left. That's this one. Okay, so we use 0, 1/2, 1, and 3/2, but we don't use 2. The width is a half, and then you do f of 0 plus f of a half plus f of 1 plus f of 3/2. And when you get done and do all your math, you end up with 3.75. I'm going to let you plug these in and get the y values. Okay, see if you get the right answer. Okay, if I switch and do right, I'm here. And this time I don't use 0, but I use 2 instead. But the width of my partitions is still a half. So I have f of 1/2 plus f of 1 plus f of 3/2 plus f of 2. When you get done doing the math, you get 5.75. I'm going to let you figure them out. But you'll notice this one we started at 0 and left out 2. This one we started at a half and you included 2. Now when I switch and do midpoint, I need the points in between. The width is still a half, but then I need f of 1/4 plus f of 3/4 plus f of 5/4 plus f of 7/4, and you end up with 4.625. Okay, that's all there is to it. The width, you take the starting and ending, divide by the number of intervals you need. So I know it's a half. We factor it out to the side. Then you decide which y values you need to include. There's 4 partitions, so you better have 4. All right? And you get different answers. And they all should have a unit squared on them because you're finding the area. You're estimating the integral. Okay? I wrote in the answer for example 6 and the one for your turn. You can work them, see if you get them. This one I wrote in the answers. I want to do one with a table because it's different. Okay? It says it's continuous on the closed interval, has shown. Here's the subintervals from 0 to 2, 2 to 5, 10 to 14. What's the approximation from 2 to 14 using right-hand sums? So this petition goes from 2 to 5. So 5 is the right hand. So I need f of 5 times the width of the partition. Well, the width of the partition is 28 minus 12, which is, nope, that's not what we need. Yep. Nope, sorry, I lied. Yeah, we do need that. But the width of the partition, so you need f of 5, the height of 5, and then the width is 2 minus 5 is 3. And then the next one, the right-hand partition, is 10, so it's f of 10 times the width of that one, which is 5. You'll notice they're not the same width, and they don't have to be. This one you need f of 14 times the width, which is 4. So it ends up being 3 times 28 plus 5 times 34 plus 4 times 30. And you get 374 units squared. Okay, so if it had been, let's do this, it's not in there, but this one was right. If we wanted to do left instead, you would have done 12 times 3 plus 28 times 3 plus 34 times, that's times 5, sorry, and this is times 4, because this is the width, and that's the height. H and W. H and W. Okay? I don't know what the answer to that is. This one we couldn't do a midpoint because the halfway in between would be, what, 3.5? And we don't have a y value for it. So we can't do the midpoint. Do midpoint. All right? This one, do the same thing. They want you to do a left sum. Your answer should be 37. This one I started. They want you to do a left-hand sum. Okay, so here's the height. The height is 150. The width is 40. You need 3 more partitions, and you should end up with the answer of A. And that's all there is to Riemann sums. Good luck. Have fun.